All right, let me see if I can get this quickly. Oh, shoot, this one's pretty quick, pretty big. So I'll try to go through it pretty quickly. A student wrote the following code segment, which displays true if the my list contains any duplicate values and displays false otherwise. Okay, so this one maybe I should have left for later, but some of you may have figured it out. It's it has couple nested loops, conditional statements. So there's a lot going on here, and it might help if you have a piece of paper. We're going to try to go through it quickly, and then if I need to explain it individually, I can. Um, so my list contains any duplicate, so it's going to return true if the my list contains any duplicate values and displays false otherwise. The question, what's going to be the question? The code segment compares pairs of list elements. Setting contains duplicates to true if any two elements are found to be equal in value. Which of the following best describes the behavior of how pairs of elements are compared? Okay, so let's see if I can kind of describe what's going on here. So we're going to say contains duplicates. So basically, what this means, uh, it's gonna check. So there's a list, my list, and we just want to see if it has any duplicate values, and if it doesn't, it's false. So what we're going to do is we're going to assume that there are no duplicates, and then we're going to look to see if there are any duplicates. And sometimes in coding, there's these uh, ways that are easier to approach a problem. So in this case, what we're looking for is we set up the default state. Excuse me. The default state is that what we're looking for doesn't exist there, and then we'll look to see if it does exist. So we're looking for duplicates. We're going to assume that there isn't any. So this top part, the first line says assign false to contains duplicates. That just means we're assuming there aren't any duplicates. I'm going to start a counter j at 1, and that's going to basically check each element of that list one at a time. So then it says repeat until j is greater than length of that list minus 1. So the minus 1 is because we're looking for duplicates. So basically, you just want to go to the element before last one. So this big loop here, this first loop, the outer box with counter j, is going to go through a list of numbers, looking at each number in order one by one. Okay. So that j counter is just going to go from the first element, from the index value 1, and it's going to go up to however long the list is minus 1. So it's going to stop short of the last element with this minus 1, because this inner loop is going to look to see if there's any of those, if there's a duplicate of that number in the rest of the list. So then this white box inside the bigger repeat loop starts with a new counter k, and it sets it up to be the next element in order from j. So it takes the counter j, that's the outer loop, and adds 1 to it. So the outer loop is just looking at the list of numbers, taking one at a time and considering. So it's going to look at the first number and then check the entire rest of the list past that to the end to see if that number shows up again. And then it's going to move to the next one and check the entire rest of the list to see if that number shows up again, and so on and so forth. Uh, so this j plus 1 here is basically because we start looking at the next element and on to the end. So then basically this second inner repeat loop basically goes like, okay, well, we're going to k will go to the end of the list. So as long as until k is greater than the length of the list, is going to keep going. And what it's doing is just checking to see if the value at location or index j is equal to the value at location or index k. Now, if it is, if they are the same, then we just say contains duplicates is true. Um, and we move on k plus 1 and j plus 1. So we basically move to the next place in the loop. Um, so And then in the end, we just display. This is not the most efficient loop, and I hope I kind of explained it sufficiently enough. So let's see if we can describe it. The code segment iterates through my list, comparing each element to all other elements in the list. Um, that is not quite true because it doesn't compare them to all of them. It compares them only to the ones that come after it. The code segment iterates through my list, comparing each element to all subsequent elements in the list. That's the correct one. So basically, it's going to go iterating, or basically taking one at a time until it goes through all of them. The only thing here is like it doesn't really, it stops short of the last element, but I guess that's that's something they missed here, but that's okay. Um, let's just check C and D. The code segment iterates through my list, comparing each element to the elements that immediately follows, not just the one that immediately follows. It compares it to all of the subsequent, all of the ones that follow, um, not just the one that follows it. And the last one, comparing each element to the element that immediately precedes. No, it doesn't just check it against the one immediately before it. So the answer here for me is B. Is the one that where it says that segment iterates through my list. Again, my note is just that it doesn't quite go to the last. It stops short of the last element, but that's fine. Comparing each element to the all subsequent elements in the list. And then one more question. I'm sorry that took forever. And this one is okay. So, a student is creating an application that allows customers to order food for delivery from a local restaurant. Which of the following is least likely to be an input provided by the customer using the application? Which of the following is least likely to be an input provided by a customer using the application? Okay, so it's uh, allows customers to order food for delivery from a local restaurant. Okay, the address where the order should be delivered. Well, you need that, so that's not least likely. Um, the cost of the food item currently available for order. I'm pretty sure you need to know the cost. I mean, I wouldn't order something if I didn't know how much it is. These are like least likely, so it can be somewhat subjective. The credit card payment information for the purchaser. Uh, well, you might not need that because you could pay with cash or some other form of payment. And then the name of food item to be included in the delivery. Um, um, so we have a application that allows customers to order food for delivery. So to order food for delivery, which of these is least likely to be an input provided by the customer? Oh, input provided by the customer. Well, the cost. I'm sorry, my mistake, because all of them made sense. Yeah, because the customer would provide the name of the item that they're ordering, the credit card to pay, um, or payment. I'm sorry, yeah, or payment information, whatever it's if it's cash or check or whatever, and the address where it's going. So those three would come from the user. The cost of the food item would be, provided by the restaurant. So the wording is very tricky sometimes. Watch out for it. Even I got confused there. All right, that's all six. Thank you.